So we're going to open this up to questions and to invite the speakers to come up to run it more like a panel discussion. So we'll begin with, we have people waiting, that's great, for questions. So why don't we start here?
So Kumar alluded to the potential for increased transmissibility, potentially for clonal populations or monogenomic populations that are persisting in areas of elimination and areas where transmission has been reduced. So I'd be interested in hearing the panel explore this a little bit further about what are the potential implications for the genetic bottlenecks that are happening as a result of current activities and what this means for elimination globally.
Thank you, Julie, for that question. You know, what it tells is, if you look at every part of the world where we have reduced the burden of malaria parasites to very low levels, we always see very clonal populations. So what does it mean? I mean, one thing obvious, there are some parasites seems to be able to survive, are more fit in staying in those regions. So that's a clear indication, and also they're surviving because they have certain adaptations probably, and they're able to really survive because we don't have a perfect intervention for malaria. Our intervention tools are still, vector, human, interaction. You want to stop that, and that's the only tool that we have currently for the stopping up those parasite clones. But if you look at the characteristics of those clonal populations in different settings, you have a different kind of characteristics. Like one example that was striking for me is this parasite lineage. I talked about the BV1 lineage. That seems to be interesting population in the sense it quickly adapts to different vector populations. So that seems to be able to really adapt and changes much more quickly than some others. I mean, that's all we know, but in terms of other aspects of that, if any of other panelists want to make any comments, Sarah or others, you can make any additional comments.
I don't know if you want to comment about fitness and issues with regard to the drug resistance piece, Ariane, maybe related to outbreaks and expansions.
Yeah, I mean, in terms of the fitness, I think the fitness, again, it relates to multiple different aspects. It could be fitness against a particular drug, or fitness in terms of adapting to the vector, or fitness in terms of their survival in different host environments. In this case, what we have seen in Latin America is, for example, some of the populations that came back after the control, they were quite susceptible to SPE and other drugs, but they were still biologically adapted. For example, in the Pacific Coast, they didn't have any interesting multi-drug resistant background or anything, but whereas in other sites we do see. So it seems to be a complex issue.
I would say when there is a bottleneck, it has a reason to be there. So if it is the HRP2 deletions, when all falciparum is diagnosed with HRP2 rapid test, that is the reason for selection. If it is because of treatment failure, for instance, in the case of the HMP paraquin, there's an obvious cause why that parasite is then spreading much more easily. In other examples, it's less clear, like this 446 mutation in Myanmar is being selected for, but as sort of an intermediate phenotype of intermediate slow clearance, not leading to treatment failure with ACTs. So maybe there it is fitness and transmissibility of those parasites that drives that.
Deus, I think you're next.
Thank you so much for the nice presentations. I just enjoyed the session. I have two questions, one to Elizabeth, and then the second will be general. Elizabeth presented the way they've been doing mass drug administration, I mean, focused mass treatment, and that they have been using DHAPQ. And as we know, this is the drug that is core to elimination in the E8 countries and many other countries in Africa. And in the recent studies in Mozambique and even in Tanzania, we just saw that about 10% of the isolates had more than one copies of plasmepsin. That is an indication that we are heading for resistance to DHAPQ. Do we have any data of the status in Zambia where they have used DHAPQ for some time now? The second question is rather general to members of the panel. We are still depending on DHAPQ for MDA in Africa. So with the trend and the way it failed miserably in Cambodia, do we have any alternative based on the data we have?
Thank you very much for that question. I just want to clarify that in Zambia, we are using two ACTs. The one for treatment of cases when they come to facilities is artemether-lumefantrine. And then we've differentiated for mass drug administration. The first time we did the MDA, we actually gave artemether-lumefantrine, and the results were not, well, we immediately had a reduction in cases, but within a month, the same people were still being infected. And this is why now we have differentiated the treatment for uncomplicated cases that are found in facilities through passive treatment, and then those for mass drug administration. If you note in my presentation, I had indicated that one of our colleagues is now looking at the artemisinin resistance markers. So we don't have the results yet specifically, but as a program, we have continued to conduct drug efficacy studies, and so far, the efficacy is still very high, and we continue to use those. But we are also cognizant of that fact, and we continue then to ensure that we do monitor and conduct the surveillance.
Yes. Yeah, so I just wanted to ask the panel, what are your thoughts about artemisinin resistance showing up in different markers other than K13, because we keep hearing about resistance in other markers also. And I'm from Ecuador, and in Ecuador, where we don't see any K13 mutations, we don't see any MDR1 amplification, but we see sometimes like things that appear to be like treatment failures. So I just wanted to know what are your thoughts about it, and what would you recommend we do if a resistance was going to appear or were going to appear in a different place?
I think Sarah is...
Well, actually, Dauda, do you want to talk about treatment failures and how you might respond in terms of thinking about, you know, from a programmatic side, and we could talk about from a genetic side, but...
Thank you, Sarah. I mean, I think it is a very problematic issue so far, because I think we have some report also from Western Africa where we found some treatment failure and without any mutation in the K13 or sometimes from the partner drugs. But first of all, what I want to make sure that people is aware is that most of the study, there is a issue regarding the drug itself use. I mean, I know from what I know from Africa, sometimes there is a quality of the drugs. Sometimes there is another aspect that's happened. The absorption of the drugs when there is, I mean, treatment, for example, with AL, where they always ask to use it with milk, for instance, before, in order to include the absorption and efficacy of the drugs. So there are problematic in terms of the use of the drugs. So I think the best way to better, I mean, tackle this is to have a full drugs, I mean, resistance, I mean, program and protocol, where we using, I mean, we combine in real time The in vivo profile where the patients are treated and followed sometimes for over a couple of weeks. The in vitro where we have some missing data for example early stage assay, because one of the studies they just focus on the molecular marker, it's like the K13 and all those partner drugs molecular marker and in vivo. But I think we need to really deeply work in the phenotype aspects with in vitro, for instance, to take this drug to do some culture, to culture the parasite adaptation and see definitely what really happened. If it's really a mutation somewhere without the known one, or if there is something that appears in the parasite itself as a known marker that was not identified. So far that's why I say it will be a tough issue to understand, but we need to further work in the surveillance system, combining all those different aspects in order to really come back with a clear answer. But again, the drug quality and the drug use will be also an aspect to consider for surveillance.
Great. Would you like to go ahead?
So, yeah, thank you very much for the great presentations. I have just one question to Professor Ndai and Professor Domdrop. I'm really interested in the resistance that you are following within both in the Greater Mekong region and in West Africa. Do you have maps to show us the genetic movements from one area to the other? Not a map of the mutations. I'm actually looking at the strains that you can demonstrate that the strains are going from one region of Senegal to the other region of Senegal, or in the case of Greater Mekong region, from say Cambodia to Thailand and Laos or whichever country. That would be really interesting to see whether if there's any data on some of those. Thank you.
Can you go first? Thank you. Yeah, I think it's something we see. Definitely, there is some parasite movement, and I think in my presentation it was clearly shown that parasite is moving. And for me, it's something not surprising because we have population movement in some real contexts, for instance, that we really leverage. In Senegal, for instance, we have some huge movement of the population during some religious events from high endemic area to the hypo-endemic area. So, and again, that's why when the NMCP came to us and tried to confirm that the parasite is moving inside of local, and in addition to the local transmission, we go back to the genetics and definitely show that, as I say, that for between 4 years, 2012 and 14, one parasite was circulating from Dakar, Chess, and came back to Richard Toll, where he stayed for a couple of years. And same thing for the vector. The vector also is moving. So that's why I think it's something to consider, really, that if the parasite is moving, we'll have importation of the malaria, but the risk of importation of resistance is what will happen somewhere, for instance, in Africa, whatever the case as it happened in Asia, can be there. Because from what I know, all the resistance, for instance, when I work a lot on DHFR, DHPS mutation with SP resistance, and as well in chloroquine. In the history of this, we see for sure that all the mutation that happened in Africa generally, most of them was coming from Asia, and it can be from continent to continent, it can be from country to country, it can be also from a local region by region in a country. It's mean we need to have a strong surveillance system in real time in order to tackle. And today, I think the only way to really ensure that there is no ongoing increasing, we can have apparition of the resistance, but the best way, to control resistance is to make sure that we have an direct intervention to stop this, the movement parasite before it spread. It's a surveillance system, a strong partnership between the research scientists in order to help the NMCPs to come back when there is a treatment failure, because a lot of people were saying treatment failure sometimes is not really treatment failure. After we do discrepancy between recrudescence to reinfection, there is not at all resistance. So again, what I'm finishing here is just to make sure we have a strong surveillance system in order to tackle all those aspects.
Arian, do you want to comment in Southeast Asia?
Yeah, so for the GMS, those gene flow maps do exist, and they're very useful, and they can be corroborated with travel surveys, because these parasites, they travel in people. Richard is doing a lot about that. For instance, we can see that the Western Cambodia, Chris Plow happens to stand at the microphone because he has done a lot of those studies. Probably moved through southern Cambodia to Vietnam. The parasites we find in Sisaket province in northeastern Thailand also come from western Cambodia, somehow skipped northern Cambodia. So those maps do exist and can give insights how these parasites travel through the region. And maybe Chris, you have additional
Comment, and then you can ask a question.
Yeah, thanks. I do have a comment and a question. I think your answer to that one was good, though, Arian. I wanted to follow up on the very first question about the implications of the bottlenecks and kind of, reducing genetic diversity. And it has to do with one of your last slides, Arian, where you showed the possible compensatory or permissive mutations for K13 artemisinin resistance mutations, which are scattered across the genome in all different chromosomes. So the implication of that WHO expert review group thought about, that I think some of you were in that a year ago, 2 years ago, I forget, was that if in order for artemisinin resistance to persist and spread and rise to prevalence, you have to have compensatory or permissive mutations on other chromosomes throughout the genome. The kind of good news was when that gets to Africa and you have a lot of polyclonal infections, after a few recombination events, that kind of constellation of permissive mutations is broken up, and that might be why you don't see artemisinin resistance really taking off in Africa yet. But the bad news would be that as you reduce transmission, and maybe as Senegal starts to look and Zambia start to look more like Cambodia, then you might see K13 taking off and spreading much more readily. That's still hypothetical, but it was kind of convincing enough that it was considered in the WHO document about the superbug. The question is, I think I saw a slide yesterday, and I can't remember which presentation it was, that implied that there are now plasmapsin 2 copy number mutants and K13 mutants in the same parasites, but there had been data earlier that maybe there was countervailing resistance. I'm looking at David Fidduck, that you either have resistance to one or the other, and you can kind of have countervailing selection. Arian or others, is there kind of an update? Are we seeing now? PFMDR1. Thank you, Diane. That the mefloquine resistance and piperic resistance are countervailing, and I thought I saw something that kind of contradicted that. Do we know where that sits right now?
Yeah, it's indeed, that was in the development of the triple therapies. One reason to combine piperacin with mefloquine was that till then we saw either plasmapsin 2/3 amplification or MDR1 amplification. Indeed, in low proportions, we now see both markers in a single parasite. Luckily, it's low numbers, and the ones we found in our track trials still had full efficacy after treatment with the triple combination, but it is a bit worrying. Yeah, I agree.
Great. Erin.
Thanks very much to the panelists. I'm curious if for each of the regions that you all are working in, what type of, whether it's platforms or use cases or personnel, what kind of sharing is there between malaria and other pathogens, for example, viral pathogens, when it comes to sequencing? And then based on that, if you could have genetic epi do any one thing that it cannot currently do, what would it be?
Good question.
Biologically plausible.
Who wants to start? Dow, do you want to start? No?
It's a very tough question.
Arian's going to start. He's pulling the mic towards himself.
So the first part, I don't think we share, but I'm not in the best position with genetic research to other pathogens and the approaches there. And the parasite is also quite different in its behavior compared to viruses. But your second question, what I would love to see in the GMS, that it would be integrated in the national malaria control programs, that community health workers or village malaria workers, every positive case, they also collect filter paper blood spots, and that is then high throughput analyzed by barcoding or whatever other technique. And I think that can contribute a lot, and that we have in near real time a view on whether we are on the right way to malaria elimination, if there's an outbreak, what are the causes of outbreaks. We have already a few used cases, as your foundation calls it, where indeed you get a lot of information out, the genetic epidemiology, just the simple thing, genetic markers for drug resistance. But the main thing is to use that in real time, in contrast what we have done all until now, that a year later we have this beautiful publication, but everything is already a year ago.
Elizabeth?
Because I was trying to really understand this real sense of the message, but what I know is, for me, it's a real need. Is a need in terms of the transmission, to measure the transmission changing in all aspects, about the control area as well the elimination system.
Do you want to talk a little bit about shared experience across viral and other kinds of pathogens? How do you think in Senegal about looking at malaria? What do you talk about, share with the teams doing other surveillance around infections in Senegal? Do you want to talk a little bit to that?
Yeah, I think today we, in the context of Senegal, where we're facing a lot of cases with fever, particularly in the north or in the central part of the country, where the transmission is declining. Most of the cases come to not to be malaria parasites. It might be also this is what we call fever of unknown. That's why today in the Senegal program, the NMCP is strongly working with other program under the Minister of Health to try to, for all cases coming at the clinics, for instance, to look for, first of all, malaria parasite. So all fever cases coming to the clinics receive malaria diagnostic tested. But does not need they feel it's all malaria, but it's just a screening process to maybe to confirm that it's not malaria parasite, to look for other diseases. It can be, and this time we will a lot of the virus, Zika, and particularly the dengue is in Senegal, as well as unknown. So I think that's why we recently we have a case from the north of Senegal in Matam, where the people was reporting, some health facility was reporting malaria, others was reporting dengue. And unfortunately, we have people died only because people was just focusing on malaria and forgetting the other disease. But when we discuss in the NMCP and receive those samples, we confirm that most of the cases was definitely malaria, but not other disease, because they feel there is no more malaria in the specific in north of Senegal. They forget the malaria, they focus on those, and the patient came to die. That's why today we have both programs to say we have a need in trauma to better understand the transmission for malaria, but also other disease. All cases coming to the hospital need to be diagnosed for not only for malaria, but for other diseases. And the genetic tools that we put in place help a lot to confirm what we're finding in terms of disease control in the context of One Health, like we work with CDC for many years as with Harvard.
Kumar, Elizabeth, you want to talk a little bit about the regions and again the integration and then Dream tool?
I think, Erin, the point is still the malaria program in many countries are vertical. Within the ministries of health, many of these programs operate in a vertical manner, when it comes to, so in that context, even sharing about not just the molecular data, even other surveillance data collections, they tend to be very, vertical. That's the kind of the way world has been operating. But in terms of how we share the kind of molecular data or other laboratory data, it again varies from region to region, but I can at least speak about what our experience has been in the context of Latin America. So there is a strong network there. This network involves PAHO, Amazon Malaria Initiative funded by the USAID, as well as the Ministries of Health. So this network is an active network where the people used to meet annually at least and then share all the data. That includes molecular data as well. So the programs were aware of the existence of the data, and they have taken advantage of that in terms of investigating the outbreaks, reintroductions, and those kind of things. And when it comes to Haiti, where your foundation funds the malaria elimination effort, that's a big consortium, and all the data different partners are collecting, but the data is actively shared with the National Public Health Lab and the program. And also some of these tools, as much as possible, we are trying to implement locally. Although at this point for monitoring for resistance or the barcode kind of work happens in collaborating institutions, our goal is to really all the database, for example, barcode data or the microsatellite data or the drug-resistant marker data, the effort is to put them together in a database and give it to the Ministries of Health, because the elimination is not an end point. Even after eliminating malaria, you still need to have a certain kind of infrastructure and surveillance system to be in place. So there is a lot of burden for the countries. So whatever the way, when we are thinking about, we all think in 2020 eliminated, the game is over. No, the countries have to still put certain level of effort to maintain that region as a malaria free. And there are gaps, and certainly that's where other players can come and help, because some of these countries, when it comes to, it is the same people who are involved in malaria control, they have to respond to Zika or dengue virus infection, chikungunya, or something else. So when that becomes the effort, real important, they drop this ball and they pick up and do that. So that's the real challenge.
Elizabeth, do you want to just?
I want to just add
okay,
one point for
quick
this.
Data.
Sorry. To come back a little, to say, for instance, it's much more need of collaboration for data sharing, not only between program and the Ministry of Health, even for the scientists system. Because what happened generally, unfortunately, most of the data are available only after publication. Sometimes it takes 2-3 years. And those will not be very useful in terms of some need, urgent need. So in Senegal, we have developed now a new program from the, what they say, disease surveillance system, where they collecting all the research data from the system. Inside of the program, we have program NMCP data, we have the others program, HIV, collect it and share. But again, they're encouraging today, as we did, to have all the data come to one day where we have epi data, and even new, like the genetic data. NMCP today is really requesting that we have the data available. And aside of a country level, today we are working with the Gambia, even with scientists, with the Minister of Health, to share data, because experience again in Senegal or in Mali might be useful for Zambia or for other countries.
Okay, comment from Elizabeth, and then David will get to you.
Well, thank you very much. I think for Zambia, we are still young. We recently started, but I think a lot of work is going on. And unfortunately, we have a lot of backlog. We have the malaria indicator survey, we have the MDA. So really, even talking of real time, we really need to start pushing to ensure that these are analyzed very quickly, and then we can go through. Talking of community, we are doing a lot of community intervention, so it will be very easy to collect the samples from the communities themselves to be able to really get that rich data and adequate samples. We have a network within the Southern African region, the elimination 8 countries, and we are looking at how we can eliminate in those 8 countries. We have the first 4 that are almost eliminating, and then the next 4 where Zambia falls. And we don't really have any of this genetic information. And we have now instances where countries are pointing fingers at each other that you've exported the parasite to our country. We have eliminated, so all these cases are coming from your country. And we don't have that evidence to show. So it would be good really to set up surveillance systems for the E8 countries so that we can track and be able to follow. Then some potential ways that can support collaboration. We have the African Union for Africa, for example, where we've set the Africa CDC. I think they could then develop these ways of sharing. And a lot of the countries are now setting up national public health institutes, which are now responsible for disease surveillance and follow-up. So I think these are opportunities where this sharing can take place. I think we did discuss with Senegal some time back, but we are yet to actualize it. Maybe we need to sign a contract today before we go so that we can quickly move and share with each other.
Thank you. David, last question.
Just a quick sort of comment and question about molecular markers in Southeast Asia. MDR1, we're pretty convinced based on in vitro data that when you change the copy number of MDR1, you don't change piperacin. So that would be consistent with the fact that you can get piperacin-resistant parasites and mefloquine-resistant parasites. So my question is, the most recent parasites that you've observed in Cambodia that are piperacin-resistant, obviously plasmepsin-2 was identified as a marker. Are you seeing any high-grade piperacin-resistant parasites in Cambodia or eastern Thailand that do not carry any of these new PFCRT mutations? Because we really think that the role of the plasmepsin-2 is to sort of aid in the physiology of the parasite because of the perturbation on hemoglobin processing by these mutations in PFCRT. And with the Pasteur network, over 90% of the parasites we've investigated in Cambodia all have these new mutations now. So we think that it may not have been the genesis of the, at the origin of resistance, but we really think that's what's driving current high-grade resistance. And I'm curious to know if you know of any parasites that are highly resistant that don't have any of these new mutations.
Yeah, thank you. I think you came in just a bit late.
I didn't realize the talk was so long. I thought it was a scheduling problem on the itinerary. Missed some of it, sorry.
I think indirectly you're referring to the PFCRT mutations that you have described in your lab. So we looked into that in our track 2 data. Those are parasites from the last 2-3 years. So interestingly, we see selection for the 145 mutation and the 93 mutation, but it's all on top of plasmapsin 2-3 amplification. But interestingly, it has a clinical phenotype that treatment failure is higher if plasmapsin 2-3 amplification is combined with either the 145 or the 93 PFCRT mutation. And it will be presented in the next symposium. It's also driving selection. There are clades that are driven by these PFCRT mutations. So I think you will be very interested in that.
So I'm very sad to say that we've run out of time, but if you have any questions for the speakers, I'm sure we can catch them now or in the coffee break. I'd like to thank the speakers for a fantastic presentation and a fascinating discussion.